of her mouth when sneezing. So this is the probability that somebody will not cover their mouth. So we call this probability of success. Remember, in binomial distribution, the success is what you are studying, you are testing. The probability that somebody does not cover their mouth is actually probability. So the probability of success is 0.267. All right. Now, let's continue. Suppose you sit on a bench in a mall and observe people's habits as they sneeze. Complete parts A to C. Part A, what is the probability that among 16 individuals, distribution sample size must be given? So sample size is 16. I'm going to put my whiteboard up because so I am going to continue this on a whiteboard. All right. So the probability that someone does not cover their mouth when they are sneezing is 0.267. So the probability of success in number 10, I'm going to write it here again. Probability of success in number 10, and what is success? That someone does not cover their mouth when sneezing, 0.267. You can imagine what's going to be success. Failure. Suppose I'm told to find the probability of failure. Probability of failure is equal to probability of 1 minus probability of success, 0.267. All right, so if I subtract 0.267 from 1, I will have approximately, so I have 1 minus 0.267. This, I want to find the probability of failure. And what is failure? That somebody actually covered their mouth when they are sneezing. So failure is somebody covered their mouth when they are sneezing. If somebody does not cover their mouth, it's success. So you can imagine this is probability for you, okay? All right, so the probability of sitting in a bench of 16 and somebody covered their mouth when sneezing is probability of failure, and that is so high though. That probability is 0.733. Okay, so the probability of failure is 0.733. In other words, if you're given the probability of success, there are only 2 probabilities in binomial distribution. If you're given the probability of success, you know the probability of failure. So probability of failure is 0.733. So that's the probability that somebody actually covered their mouth when sneezing. So we have Q is this. Okay. So let's answer the questions. So question A here says, what is the probability that among 16 randomly selected individuals, exactly 5 do not cover their mouth when sneezing? Be careful. You could be told to write, by the way, the random variable is 5 now. X is equal to 5. And by the way, sample size is 16. You have to be very careful. This is binomial distribution. You can do this by hand or with, so we can do this by. So suppose I decide to just use binomial distribution formula. Using the formula, I'm going to use formula. Using the binomial formula, binomial distribution formula. All right, so I'm looking for the probability of exactly 5. Exactly. Probability of exactly 5. This is the same thing as random variable. The probability of random variable X is equal to 5. That's what exactly 5 means. Okay, so I'm using, let me write the formula. Okay, and n is equal to 16. Remember, the formula is n combination r, success to power r, failure to, this is success, by the way. Success to power r, success to power r, failure to power n minus r, where I already know n is 16 sample size or sample space. So 16 combination, I'm talking about 5. Actually, you can write this R as X, doesn't matter. So success is 0.267 to power 5 multiplied by failure, probability of failure 0.733 to power 10 minus 5. I mean 16 minus 5. Sample size minus the random variable. So 16 minus 5 is 11. I can just put it in my calculator and multiply. Okay? So, but this is what I'm evaluating. If I like, I can just use normal probability. Oh, that's not normal. That's binomial. Sorry. So I can use binomial probability density function. So binomial probability density function. Why am I using PDF? I am using binomial probability density function because it's an exactly question. So in binomial distribution, if the question says exactly, then you are looking for one probability exactly. Okay, so now I'm going to put in what I know. The argument is NPR or NPX, depending on what you call your random variable. So N is 12, 16. R is the probability of success. Remember, it is somebody does not cover the amount, 0.267. And R is the number you are checking out, number you want at a time. So I can just put this in my calculator quickly. So what is this probability that you sit in a mall and 5 out of 16 did not cover the amount when they are sneezing? Okay. So where do I go to find binomial PDF? Second distribution. And I'll arrow to binomial PDF. And number of trials is 16. How many people are you testing? Sample space or sample size. Probability of success is the probability of those who did not cover their mouth when they were sneezing, 2.267. And how many are you testing at a time? I'm taking 5 of them at a time. What is the probability that when you watch 5 people, what's the probability that they're not covering their mouth? 5 out of 16 did not cover their mouth. So I'm going to calculate. So that probability is 19.45. If that probability is 19.45, then the reverse, the 1.19.45 will cover their mouth when they're sleeping, when they're sneezing. So the probability is, in percent, is 19.45%. Therefore, if I take 5 people at a time, that is a probability of 19.45 that they will sneeze and not cover their mouth. That's what I just found. There is a high chance that they sneeze and they will not cover their mouths. So that is a question 10A. We just answered the question 10A. The probability that you choose 5 out of 16 and exactly 5 of them did not cover their mouth when they are sneezing. Okay, so let's go to question B. We'll actually stop at B so that we can get to others. So let's look at question B of number 10. All right, in question B, this question says, okay, what is the probability that randomly observed individuals, fewer than six, do not cover their mouth when sneezing? By the way, what does that mean? Fewer than 6 means only less than 6. Less than 6. And when you are told less than 6, 6 is not included. You have to be careful with this inequality. 6 is not included. Fewer than 6 means 6 is not included. You got to be careful. Okay. Okay, so I am going to, first of all, my whiteboard and write what I am given. So in question B, the probability, sample space is still 16. The probability of success this time, probability of success or whatever, random variable, let me just say random variable. Probability of success is still the same thing, 0.267. And the random variable x, I am just going to put in less than or equal to 5 because 6 is not included. 6 is not included. In other words, I am looking for P0 plus P1 plus P2 plus P3 plus P4 plus P5. And I hope you understand what P means. P0. For a reminder, P0 is sample size combination 0 multiplied by success 0.267 to power 0, and failure is 0.733 to power 16. That's 16 minus 0. If you put this in your calculator, you get an answer. Then you do the same thing. P1, this is P0, P0. But I'm not doing them one by one because it's going to take all the time I have. So I want to do CDF. This time I am going to do cumulative density function so that I will not use one, I will not be answering one question and it will be over. You have 20 questions to answer in 1 hour, 1 hour, 30 minutes. And then if you keep wasting time, you are tested on speed and accuracy. So you should know how to use your calculator fast. And so you do not want to be doing P1, P2, P3 until you get to P5. This is what you have to do. So I am going to show you how to answer this question first and get to other questions and make an A in this test. So what you're going to tell your calculator is, I'm looking for binomial cumulative density function. Why? Because binomial cumulative density function is cumulating to the left. So now I am going to put in sample size, and sample size is 16, sample space or sample size. Probability of success is 0.267, and the number I want at the time is it's not going to be 5. I mean, it's not 6, so I'm going to put 5 because 5 is the lower random variable after 6. So you pick the lower number. Why? Because it says less than 6. question said less than 6. So 6 is not included. You have to be careful when answering this kind of question. Okay, so you're accumulating to the left. In other words, you're finding P0 plus P1 plus P2 plus P3 plus P4 plus P5. And by the way, what is the P0? P0 is the probability that 0% did not cover her mouth. P1 is the probability that 1% did not cover her mouth. P2 is the probability that 2 people did not cover their mouth. P3 probability that 3 people did not cover their mouth. Remember what P means, success. And success for this question is what we are studying, the probability that people do not cover their mouth when sneezing. That is success in this question. So you have to be careful. All right, so now I am going to pull my calculator up and feed it with what I am looking for so that I make sure I have speed and accuracy, pass the test, make a good grade. You have to be careful, pass the test and make a good grade. Do not waste time because you are allowed to use your calculator, and by all means, use it wisely. So I'm going to do second distribution. Then I go to binomial. I'm doing binomial. And this time I'm cumulating from 0 to 5. So binomial cumulative density function. Number of trials is 16. That's the sample space. The probability of success is the probability of those who did not cover their mouth, 0.267. And the number I want at a time is 5. I'm accumulating from 5 below. And then if I hit enter and then I calculate, it's a whopping 73.3% of people it's expected out of probability. The probability that less than or equal to 7 did not cover the amount, 5. Less than or equal to 5 did not cover the amount is 76. I'm writing it in percent. 76.3% in percent. Don't forget to put percent if the question says percent. If the question says decimal, put 1 decimal point, put a point. By the way, let's see what that question says. This say 1 decimal point. If it's in that 3 decimal point, it's 0.763. So make sure you check what the, okay. So this is the probability that we just calculated. Okay, so let's go to the next question. And by the way, the number of decimal points round to 4 decimal places. So you can round your answer to 4 decimal places. Okay, would you be surprised if after observing 16 individuals, fewer than half covered their mouths when sneezing? So if you are testing fewer than half cover their mouths, then you are actually testing greater than or equal to half did not cover their mouth. They are the same. Would you be surprised if after 16, fewer than half covered their mouth? Because the probability of success is those who did not cover their mouth. If fewer than half covered their mouth, then greater or equal to half did not cover their mouth. That is, which means we're going to do a complement. And whenever you do a greater than or equal to, it means you are doing 1 minus. So this question is a greater than or equal to, because remember what P means. P means probability of those who did not cover their mouth. So if you see, if they try to switch the question and tell you cover their mouth, you better remember what success means. So if fewer than half cover their mouth, then greater than or equal to half did not cover their mouth. So are you going to be surprised? So I'm going to calculate the probability, then I will answer the other questions. All right, so first of all, I'm going to write what I'm going to put in there. So I'm going to scroll up, and then probability of fewer than half cover their mouth. So this is C. Probability of fewer than half cover their mouth. Fewer than half covered their mouth is the same as probability of greater than or equal to half. Greater than or equal to half their mouth. And by the way, what is half of them? What is half of 16? Half of 16 is 8. So I'm going to put 8 here. Greater than or equal to 8 did not cover their mouth. Did not cover their mouth. No matter how they write the question, you want to make sure you think about it and you write it the way that you are still using the probability of success. Probability of success is the probability of those who did not cover their mouth. So when we are writing this question, so that probability of success. All right. So now, what do we know? N sample space is 16. The probability of the random variable, those who did not cover their mouths, greater than or equal to 8. Okay. And then the random variable, this is what I'm going to use. And the probability of success is still the same, 0.268. Okay. So what am I going to tell my calculator? Now, this is an at least question. In binomial distribution, in an at least question here. Okay, so I will do 1 minus binomial CDF. And in binomial CDF, this is 16 total. The probability of success is 0.268 and greater than or equal to, so 8 is included. I cannot subtract 8. So I am going to put 7 there because it says fewer than, so the there is a number less than 7, fewer than half. Okay, so now I am going to tell my calculator what I want to calculate. So what do I want to calculate? I want to calculate, I'm going to clear 1. So this is complement rule, 1 minus, whenever you are doing an at least question, it's a complement. Binomial cumulative density function, which is B. And then the sample space is still 16. The probability of success is the same. The value here should be 7, fewer than half. And I am going to calculate. All right. Remember that we did 1 minus because this is an at least question. In any at least question in binomial distribution, you are doing 1 minus. So I am going to hit enter. And the probability that fewer than half cover the amount is 0.03, 0.039. Okay, let's see, to 4 decimal places. 395. Okay, so this is the probability. Okay, so let's see what other questions they have there. So let's see what other questions they have. Well, would you be surprised if after observing 16, fewer than half cover the amount? Why? Okay, so you calculate the probability and then, okay, be surprising, because using the binomial distribution, the probability, you put the answer here, and then